Okay, so we're going to begin by drawing a triangle here. I'm just going to make it a scaling triangle. I hope, yeah, all three sides are different there. So this is a scaling triangle. I say scaling because some kids will sometimes draw like a special, like an isosceles or a equilateral triangle, and then use techniques to inscribe a circle that won't work for all other triangles. So we want to find the point inside here that is equidistant from the three sides. Okay, how do I find the point that's equidistant from the three sides? Some point here in the center. That'll be the center for our circle, and it turns out we'll call it, because it's in the center, we'll call it the incenter. Okay, so what we want to do is we want to find, let's just think about finding the points that are equidistant from side A and side B. Where would those points be? Well, it turns out they would be the points on the angle bisector, right? So if I constructed an angle bisector for angle A, B, or ACB, I'm getting that these two sides are now equidistant, or these points are equidistant from these two sides. So what if I want the points that are equidistant from these two sides, B and C? Well, I could say, give me the angle bisector there. These points are equidistant from those two sides. And this point should be equidistant from, because it's on both bisectors, going to be equidistant from here, here, and there. We could also try bisecting the third angle. And notice that they all intersect at the same point. They all intersect right there at point D. So what do we do to find our center for our circle? Now, be ready and maybe make a note of this, because you'll need to explain it. To find our incenter, which is the center used to inscribe a circle, we use our angle bisectors. Our angle bisectors will give us the point that is equidistant from the sides. So to draw a circle, we need to know a center. We also need to know what? A radius, a distance. So how far do we drag this circle? If I made a circle from here, D, how far out would I make the radius? Well, just enough to just barely touch this side. So how do I find that? Well, it turns out that if I construct a perpendicular line, right, perpendicular to this side that goes through C, or point D rather. So from side C, I'm going through point D. And then I find that intersection point of side C and that perpendicular. I get point E. Now I have my radius. So if I draw my circle from center D to point E, it will in fact be inscribed perfectly. Now what's interesting to see about this is that it'll work for any triangle. It doesn't matter how I modify the triangle. Okay? Doesn't matter how big or small I get it, because we found the incenter by bisecting the angles. So as long as I, if I just keep modifying this triangle, but as long as I keep bisecting the angles, I'm always going to find my incenter, and I'm always going to have the radius perfect, because I found my radius by constructing the perpendicular from D to point E. So I'm pretty much guaranteed here that no matter how I change the vertices, I'm going to have an inscribed angle. Let's make those notes real quick, and then you'll be able to do yours. Here we go. First note. First, find the incenter by bisecting all three angles and finding the point of concurrence. Okay, so what does that mean, concurrence? Well, this funny word concur, it means to agree. So when we say finding the point of concurrence, that means the point where the three angle bisectors agree, or rather where they intersect, right? It's another fancy way of saying it. The point where they intersect, okay, is the point of concurrence. So that's our first step. What's our second step? Second, draw a perpendicular to a side that runs through the let's write it down here. I'm going to make this all fit together. That runs through the incenter. Right? find the intersection point of the side and the incenter. Draw your circle with center at the incenter and radius to the intersection point of the side and the perpendicular. So that's the steps that we took here. Let's draw it. Let's go through them again. First, I bisected the angle, and that gave me point D, the point of concurrence of the perpendicular, or the angle bisectors rather. So now I knew that that was the incenter. Then the next thing I did, you can see in here, boy, it almost like an optical illusion when I zoom out. It almost looks like the circle extends beyond the triangle, but it does not. So I found the angle bisectors first, right? Then the next thing I did was I drew my circle. No, I'm sorry. Then I drew a perpendicular from a side. So in this case, I drew it from side C through D. Then I found the intersection point between that side and, not the incenter, that's goofy, between the side and the perpendicular. Side and the perpendicular. And then I drew my circle with my center at the incenter, and the radius is to the intersection point, which in this case was E, right? That was on this perpendicular. Okay, so there we go. That's how we did it.